welcome back. If you have ever trained a model that worked beautifully in your notebook, then had no idea how to ship into production, then this video is for you. So we are talking about MLOps today. So basically, how real team take a model that works beautifully in your notebook to a reliable system running in a production. And at the end, we are going to build a mini pipeline that train, track, and monitor the model in a production system. So here are the uncomfortable stats. Now 87% of the ML project never make it into production. So the pattern is consistent everywhere. Most of the model die in the notebook only. The gap isn't the modeling itself. The real thing started after packaging it, deploying it, and keep it until the real user hit it. Let's be very honest about why this is very difficult than shipping a normal software project. So here are the four category I have found out, as you can see in my screen. So failure are silent. So basically, a degraded model quietly give a worse answer, and nothing give you uh, an any alert by default. Second one is data quality depend on the data. So basically, your model is only as good as data hitting in production. So once the real user hit in new cases, new scenario, and new edge cases, we need to came across. So in the normal software, a code is the only thing that keep we need to manage. But in case of ML system, we have like code along with the uh, real world user, which keep moving one after another. And there is no single bug to fix. Performance is graded on the curve, and 94% accuracy today, and the next day is 91% in pass or fail. Simple definition, MLOps is a set of practice that combine machine learning, DevOps, and data engineering to deploy and maintain ML systems in production reliably and efficiently. You can think of a DevOps as a CI/CD automation and deployment. On top of that, if you add data and model training, drift, versioning, and reproducibility, you will get MLOps. So let's get specific about how MLOps differ from DevOps uh, practice. So at one end, DevOps ships a code, whereas MLOps ships code plus data plus model. DevOps ships version source code, whereas MLOps version code, data, and model weight. MLOps DevOps test logic correctness, whereas MLOps test data quality and model performance. DevOps fail loudly, whereas MLF fails silently, only because degraded model give you the worst answer you can imagine. So at the end, MLF doesn't replace DevOps actually. It extends the same discipline to harden data and model. So how ML lifecycle look like end to end? So these are the five stages are the backbone of ML lifecycle. We are going to cover rest of the video. So first it start with data, then training, then deployment, and then monitoring. So once model fail, then again we will go back to training. So naturally, pipeline with these many stages need a tooling at all every stage actually. So ecosystem is used. So you don't need everything basically. So this is a map. So you should know these exist. So first is like for experiment tracking and metadata storage, we have MLflow, and for storage we have DBC, and for workflow orchestration we have GenML, and for a deployment we have NVIDIA TensorRT Sheldon Co. And for observability, we have Evently AI. And for data labeling, we have Labelbox. And for end-to-end ML platform, we have a popular tool called Databricks and Amazon SageMaker. So yeah, we have understood the ML ops life cycle. So now let's get started with the small practical example. So we have set up this project, and we have installed dependency, MLflow dependency and scikit-learn dependency, and along with the pandas and numpy, as you can see in the screen. And first I will generate synthetic customer data. Basically in the real life, uh, this data comes from database, Kafka, data warehouse, and data lake. So as you can see in my screen, we have generated customer churn data, and it has a features like tenure, month, monthly spend, order per month, support tickets, user discount, and app session and churn. So this is important observation. You can see it is generated 5,000 row and churn rate is 9.36. So it is only around 8 to 9% of the customer churn, which is mean this is an imbalanced data set. So now I'm going to train our first random forest model. So essentially ML experiment start. First we load dataset, then we split our dataset into training and training, and after that we train our model, and then we print some metrics. So as you can see in our screen, we have accuracy around 90%. At the first, it will look okay, but remember only around 9% of customer data churns, so accuracy alone can be misleading for an imbalance problem. That's why we are looking for AUC.
Fourth thing I would like you to notice, first is we log model type and hyperparameter. Second, we are training the model normally. Third, we are logging how well the experiment performed. And fourth is we are saving the model artifact. Also, we calculate MD5 fingerprint of our CSV dataset. Why? Because model performance is meaningful only if we know exactly which data produced it. And next, we are going to run the experiment. And for that, we have six experiment, three for logistic regression and three for random forest experiment. So let's get started with each experiment. So first, we are starting with logistic regression, and we have three experiment with that. First done, and then we start with second one. At the last third one. So we have completed with logistic one. Then we will start with the random forest. Second random forest experiment done. So and the last we have completed random forest experiment.
Now I'm going to start MLflow in a separate session, separate terminal basically. So this is where MLflow become much more useful. Instead of comparing terminal out manually, now I have a central experience dashboard. So as you can see in my screen, by default cart vista churn experiment it is getting created. If you click on that, so it will show whatever run we have executed in the terminal. As you can see in the screen, we have a three logistic regression run and we have three random forest run, and we can add various parameter. We can add test accuracy, and we can sort by ascending order with accuracy score. As you can see, and in any of the run, we can have artifact wise, like what are the model which we are running, and model prediction score, that is also we can have in this artifact one. And once we have everything, we can click on, and we can compare all the run as well, as you can see in my screen. So this is a much better way of comparing instead of manually comparing terminal output. As you can see in my screen, we have we can filter out with the run detail, parameter wise, metrics wise. So this is where MLflow become very useful actually. So next step is we will register our model actually. So in order to do that, which model our application should actually use. So where the model registry comes in, this script searches all the experiment files, the model with the highest test EUC, and register under the name chart vista churn, and then assign alias champion. We have run model registry. After that, we can see it has assigned alias champion in our cast vista churn. Now the next step is model conjugation. Basically, it simply answer, give me a champion model for cast vista churn. So now we will run that script. You can see it is given the output. So that's the so at this we have started with the small script. It generated the synthetic data. Then we have trained the model. Then we have added ML workflow. So basically, from start to end, we had data, then experiment training, then model registry. Then we had a metrics, and then we have a prediction as well. So this is how these are the core principle of ML flow. So